Hello, this is Mr. Newman, and I'm going to talk today about the difference between power functions and exponential functions, and we're also going to talk about concavity. Okay, so let's get started by talking about what are the equations for power functions and exponential functions. Well, the equation for a power function is as follows. Y equals a times x to the b, where a and b are constants, okay, so they don't change. So an example of a power function would be y equals 3 times x to the 2.5, okay, just as an example. You'll notice if b is an integer, for example 2, 3, 4, 5, then we actually get something, we actually get a different special kind of power function. So we typically look at power functions where we have decimals as b's and whatnot. Now for exponential functions, the equation is as follows. Y equals a times b to the x. Now you might notice that the only difference between power functions and exponential functions are the x and the b switch places. So it can be tricky to remember. A mnemonic device I tried to come up with was that you can remember that exponential functions have x in the exponent, because they're exponential functions. If that helps you at all, then good. If not, then come up with some other way to differentiate between these two so you don't get them confused. And an example of an exponential function would be maybe y equals 2 times 5 to the x. Okay. Now, if we look at these on a graph, your power function looks like this, and the exponential function looks like this. And you'll notice a few things. Now we're going to do a lab where you examine these more in detail, but I just want to give a few tips. And on the lab you will be expected to write more than just this. But you notice that the power function intersects at 0, 0. Because if you look at the equation, if you have x being 0 right here, then that means 0 to the b, no matter what it is still going to be 0. So you get y equals 0. However, on the exponential function, if you have x being 0, where you have y equals a times b to the x, now b to the 0 becomes 1, so you actually intersect. Y is not 0, it's a point above 0. Okay, so that's one easy way to tell the difference between exponential and power functions on a graph. Now, not all exponential and power functions look exactly like this. On power functions, you might have some other ones. Let me change colors real quick. You might have it look like this, or it might look like this. Okay, there are lots of variations, or even like this. Okay, lots of variations, all dependent on what a and b are, and we're going to look at those more in depth in our lab. And in exponential functions, you'll have them looking like this, or maybe like this, okay, and we're going to talk about what changes those, and you'll get to see that. Alright, so before I give too much away, let's talk about concavity. Now, concavity simply means the direction the line curves, okay? So it either curves up or it curves down, alright? So, for example, a power function that looks like this, we would say is concave up. Now, you might say, Mr. Newman, this curves up and to the right. Well, concavity we only define as up or down, so since it points slightly up and slightly to the right, we say it's concave up. Okay. Another example, a different example, you might recognize this. This would be like your x squared. We call this concave down because it points down. All right. Similarly with exponential functions, if you have something that looks like this, okay, that would be concave up, because it points up. And say you have something that looks like this, okay, even though it's going up, alright, it curves down, so we'd say that's concave down. Alright, I hope that helps with concavity. One last thing I want to comment, and then you can answer your question, is you might be asking, okay, Mr. Newman, what if it doesn't point up or down, okay? Well, if it's a straight line like this, then it has no concavity, okay? But if it curves, let's say it only curves to the right or to the left, it might look something like this, okay? Now, for your question, I want you to answer, why would we not see this kind of line or this kind of graph with a function, alright? And I'll leave that question here for you, and you can go answer it. And my only requirement is that you use the words inputs or outputs in your answer.